Hey there, physics students. So we've talked about the metric system in our last lesson, and we've learned about the kinds of units that we use to measure things in science. And now let's talk a little bit about the numbers that we use, because the numbers that we use in science are a little bit different than the numbers that you might use in math, right? In math, you work with numbers that they call pure numbers. When they say 4, they mean 4, and it's exactly 4, right? But when you measure things, there's always a little bit of uncertainty involved, right? What we're dealing with aren't pure numbers, they're measurements. And there's always going to be a little bit of uncertainty involved in them. And so in order to keep track of that uncertainty and to kind of learn about it a little bit, we're going to learn about what they call significant digits in this lesson. And our target here for this lesson is to be able to attend to precision in measurements. So let's go ahead and we'll talk about significant digit. We'll talk about the idea behind what this is, and then we'll talk about how we use it when we do physics. So let's go ahead and talk about that. Alright, so here I have a book, a physics book, and let's say I want to measure how long is the book going across. Okay, simple enough. I have a ruler, right? Now if you take a look at my ruler, this is a great ruler, right? You see it's got this section here and this section here, right? Each section is 10 centimeters long. So what's the best I can measure with this ruler? Let's take a look. Let's try this. When you measure, you should really put it down on the table and, lay it flat and stuff, but you won't be able to see that. So let me hold it up like this. Okay, if you take a look, it goes more than 20 centimeters. Take a look, see it goes further than that mark right there. That mark right there would be 20 centimeters long. It goes further than that, right? So it's more than 20 centimeters long. How many centimeters is it? Well, is it 30 centimeters long? No, it's more than 20. It's less than 30, right? But can we do a little bit better than saying it's 20 centimeters long? I mean, if we look at it, it's clearly not 35 centimeters long. It's, maybe we can estimate that. Maybe it's just a little bit more than 20. Looks like it's probably even less than 21 if we estimate that pretty well, right? So how long is my book? What's the best I can say? It's 20 point something, right? I don't know. My ruler wasn't so good. But maybe I can do better. Maybe I can measure it with a better ruler. Here, I have a better ruler. You see, this ruler is not just marked every 10 centimeters. This ruler is marked every centimeter. So let's put this ruler up against our book and see how long is our book. And again, you should lay things on the table when you measure them. We're going to do the best we can here. See, okay, there's 20. Right there's 21. It looks like, you see, it goes further than the 20, but it doesn't get to the 21. Right? So how long is my book? It's 20 point something, right? We can probably estimate it's less than 20 and a half, right? So maybe you can say that's maybe, 20.4, 20.3, something along those lines, right? But exactly how long is my book? I don't know. My ruler wasn't good enough to measure exactly, right? So every centimeter, and it wasn't good enough. I got another ruler. This one's even better. This one's not just marked every centimeter. This one's marked every 10th of a centimeter, every millimeter. Let me use this ruler and let's try to see how long is my book. So I'm going to put it on here pretty nice. And again, you should lay it flat on the table, but then you won't be able to see it. So I'm going to hold it up as best I can. So we'll take a look there. And you can see there's 20 centimeters and there's 21 centimeters. And that's the back of the book, you can see there. Okay, you kind of look at it like this, okay? Okay, so there's 20.5 is that longer line right there in the middle. And it looks like it doesn't quite go to 20.5, but it looks like it goes more than 20.4. So maybe it's 20.45. Right? Point being, okay, as good as you make your ruler, keep in mind this ruler is definitely a lot better than this ruler. right? But however good your ruler is, it's never going to fall exactly on a mark on your ruler. We can have the best ruler in the world. We can have such tiny little tick marks. We could have 10 tick marks between each one of those marks. It's never going to fall exactly on a line. And so there's always some amount of uncertainty with your measurement, right? So with my first ruler, when I measured that book, the best I could say is it was about 20, right? The second one, keep in mind, it only measures to the centimeter, but I could estimate it a little bit better. Usually what we'll do is we'll estimate one digit beyond what we're able to measure. So with my better ruler, it was definitely 20, but not 21. And you remember we estimated it as maybe about 20.5, right? So usually we'll estimate one more digit than we can actually measure. And then with our even better ruler, with our best ruler here, we said it was 20. It's a little bit more than 20.4, but a little bit less than 20.5. Maybe we can estimate it as 20.45 centimeters, right? So with this one, I can estimate it to the centimeter, even though it only measures to the tens of centimeters. With this one, I can estimate it to the tenth of a centimeter, even though it only measures to the centimeter. And this one, even though it only measures to the tenth of a centimeter, I can estimate it to the hundredth of a centimeter. One more place than it actually measures. So here's the question. If I told you a measurement, would you be able to tell me which ruler I used to make that measurement? So here's some measurements, right? Can you tell me which ruler did I use to make each one? You see the first one up there? 16.2 centimeters. Which ruler did I use to make that measurement, right? Okay. Was it this one? This one can only measure to the tens of centimeters. So you could estimate to the centimeter. But this is to the tenth of a centimeter. So it wasn't that one. What about this one? This one can measure to the centimeter, which means we can estimate to the tenth of a centimeter. You see, tenth of a centimeter, which means we used this ruler to make that measurement. What about the second number there? 3 centimeters. Could it have been this one? Well, I could definitely measure 3 centimeters on this ruler. It's right there. But then I would also estimate one more digit. So I used a ruler that was less accurate than that. And I only have one other ruler that's not as accurate as that, and that's this one, right? Well, we can only measure to the tens of a centimeter. We can estimate to the centimeter. So 3 centimeters, I used this ruler. And of course that last one, where you can see it's estimated to the hundredth of a centimeter, I would have used a ruler that was marked to the tenth of a centimeter, right? So I would have used this ruler to make that third measurement. Okay, so when you look at a measurement, you can tell something about the accuracy of the tool that was used to make that measurement, right? When we report measurements in science, it's very important to keep our numbers straight so that we, whoever's reading our work knows what the accuracy of the instrument we used was. Okay? And in physics in particular, we're going to do lots of calculations that involve measurements. And as we do calculations involving measurements, what we're going to need to do is we're going to need to track that accuracy through our calculations. And I'm going to show you how we do that. Okay, in the first step, we need to understand something called significant digits. So let's go ahead and talk about significant digits. Now here's the thing. Okay, significant digits, sometimes also called significant figures. The two terms are interchangeable. I might say significant digit, I might say significant figure. They mean the same thing. Interchangeable terms. Okay, consider this measurement right here, 2,300 centimeters. What type of instrument did we use to measure this? Okay, did I use an instrument that measures to the 1,000 centimeters and then estimate the 3? Or did I use an instrument that measures to the tens of centimeters and then estimate the ones. Which way did I do it? Okay. Now, kind of the convention is if you don't see a decimal point in that number, these zeros were not measured. Sometimes numbers in digits in a number are only there to hold a place, and they weren't actually measured, right? See these zeros? We didn't measure those. They're placeholders. They need to be there, right? If they weren't there, this number would be 23. And 2,300 is definitely not the same as 23. So those zeros need to be there to keep track of that place, right? But they're not measured. They weren't measured. They're just placeholders. These zeros are not significant. Okay? And that's the idea with significant digits. Significant digits are the numbers that we measured or estimated, not the numbers that just hold a place. Okay? And a clue here is that the only numbers that are just there to hold a place are zeros. So the first rule with significant digits is any digit that's not a zero is significant. Consider this measurement. You can see in this one we have 2 zeros in that number, but one of the zeros is between numbers that aren't zeros. Okay? When you look at this number, that last zero right there is just there to hold the place. That one is just a placeholder. It's not significant, just the same as in the last example. But what about that zero? What about the zero that's between the 2 and the 3? Is it just a placeholder, or is it something that was measured? Okay. Well, I'll tell you what, if I was able to estimate that 3 that's in the 10th place, then I was able to measure what was in the 100th place, right? I can't estimate this if I can't measure that. So that zero, the zero that you see that's between significant digits, is significant. So as we determine which digits are significant and which digits are not, only zeros can be not significant, but sometimes zeros are significant. So in this particular example here, that last zero is just a placeholder. It's not significant, but that zero that's between the 2 and the 3 is significant, right? So the second rule with significant digits is zeros that are between significant digits are significant. I would look at that number and say it has 3 significant digits, the 2, the 0, and the 3, and then the other 0 is not significant. Okay, in this measurement, you can see something a little bit different. You can see in this one, we have a 2 and the 3 that we know are significant because of the first rule. The first rule said that digits that aren't 0 are significant. You know the 0 that's between them is significant because of the second rule that says that a 0 that comes between significant digits is significant. But what about these zeros at the beginning? Were those zeros at the beginning, were they measured? Or were they just estimated? Or are they just there to hold the place, right? Well, zeros that come before the first significant digit aren't measured. We didn't measure those zeros. Those zeros are just there to hold the place. They're placeholder zeros. So I like to say for the third rule, I call them leading zeros. Zeros that come before the first non-zero digit. Leading zeros are not significant digits. Okay. So in this measurement here, there are 3 significant digits. The 203, and then the first 2 zeros are not significant. It doesn't matter which side of the decimal point they're on. If they're leading zeros, they're not significant. Okay, what about zeros that come at the end of a number? Look at this top number up here, 3,000. So you've got a 3, which is definitely a significant digit because of the first rule that says any number that's not a 0 is significant. So that 3 is definitely significant. But what about the zeros there that follow it? Zeros that come at the end of a number, I call them trailing zeros. It depends. Okay, it depends on what else you see there. If there is a decimal point in the number, if you see a decimal point written, then those trailing zeros are significant. If you don't see a decimal point written, they're not significant. Okay, so in this number here, 3,000, those 3 zeros are not significant digits. I would look at that number and I would say that that number has one significant digit. It's just the 3. Okay, but what about the next number, 3.0? Is that 0 significant or not? Well, I can see a decimal point written in that number. So that 0 is significant. So that number right there would be 2 significant digits. And that's a big difference between writing just 3 and writing 3.0. Very often you're going to see written 3.0. And sometimes people say, why do you write the 0.0? Isn't that the same thing as just 3? Well, no, it's not, because 3.0 is more accurate. It's more precise than just 3, right? It's got 2 significant digits rather than just 1 significant digit. What about this third one right here, 30, with the decimal point? You see, I chose to write a decimal point there. You might say that number doesn't need a decimal point, but that decimal point, what it's doing is it's making the 0 significant. So I can see that number 30 point, and I know it has 2 significant figures. That 0 is significant. Whereas if I had written it without the decimal point, it would only have 1 significant digit. It would be like the first one up there, 3,000, and the 0 would not be significant. So the fourth rule for significant digits is that these trailing zeros are only significant if you see a decimal point in the number. Alright, the fifth rule for significant digits has to do with numbers that aren't measured, things that are counted rather than measured. Like, for example, 18 cars, right? I go out in the parking lot and I count there are 18 cars out there. Did I measure that? I didn't really measure that. Is there any possibility that there's 18.2 cars in the parking lot? No, we usually don't measure cars in fractions of a car. So, I mean, it's only something that can really be a whole number. It's something that I counted rather than measured. If you have a number that's something counted rather than measured, we say it has an infinite number of significant digits. Also going along with this, things like conversion factors, numbers that you use to convert between units. So if I say there's 10 centimeters or 10 millimeters in a centimeter, that 10 is a counted number rather than a measured number, right? And we say that it has an infinite number of significant digits. Even though there's only 2 digits there, it has an infinite number of significant digits. It's infinitely precise. Okay, so counted numbers, conversion units, things along those lines. Sometimes there's a number that's in an equation already. That number is also like a counted number. It's infinitely significant, infinite number of significant digits. So rule number 5, counted numbers have an infinite number of significant digits. Okay, so how many significant digits are in that number? Well, let's think about it here. We've got, by rule number 1, we've got a 1 and a 3 that are not zeros. Rule number 1 tells us any digit that's not a 0 is significant. So the 1 and the 3, definitely significant. Okay, what about the 0 that's between them? Rule number 2 tells us about between zeros. Rule number 2 tells us that between zeros are significant. So that 0 is also significant. What about the 0 at the end, the trailing 0? Well, rule number 4 tells us that trailing zeros are only significant if we see a decimal point. Do we see a decimal point in that number? Yeah, we do. So that trailing 0, it is significant. So which digits are significant? All 4 of them are significant. So if I asked you how many significant digits are in that number, you would answer, there are 4. All 4 of those digits are significant. How about this number? How many significant digits are in that number? Well, by rule number 1, we can look at the 2 and the 3 and we can say, yeah, those 2, they're definitely significant, 2 and 3. What about the 0 that's between the 2 and the 3? Is that one significant? Yep, rule number 2 tells us that between zeros are also significant. What about the 0 that comes at the end? Is that one significant? That's a trailing 0. Well, rule number 4 tells us that trailing zeros are significant if there's a decimal point in the number. Is there a decimal point in the number? Yeah, there is. So that 0, also significant. Okay. And then the question is, what about these 3 zeros that come at the beginning, 0.00? Are those significant? Well, rule number 3 tells us leading zeros are not significant. So those 3 zeros are not significant. So how many digits in that number are significant? Well, 0.00 are not, and then 2, 0, 2, and 3 are significant. So that means there are 4 significant digits in that number. There's 7 digits in the number, only 4 of them are significant. So I would answer and I would say there are 4 significant digits in that number. Okay, now that we know how to determine which digits are significant, which digits aren't, we're going to need to be able to use this as we go forward in class to keep track of the precision of our measurements as we do calculations. So if we're going to add something, subtract, multiply, or divide, how do we keep track of that precision? Because when I do a calculation, my answer that I get can't be any more precise than the numbers that I started off with, and the measurements that I had at the beginning. Right? So if I've measured 2 things to the 10th of a centimeter and I multiply them, the answer I get is going to go out to the 100th of a centimeter. And did I measure anything to the 100th of a centimeter? Why would my answer be more precise than the measurements I started off with? Right? So we need to know how to keep track of this as we do our calculations. So let's talk about adding and subtracting, which actually doesn't involve significant digits. But we'll do it a whole lot less often than multiplying and dividing, which does involve significant digits. So let's look at adding and subtracting. It's both the same way. So let's just look at an addition problem. When we add 2 numbers, what we want to do is we want to round our answer to the least number of decimal places. So let's look at this. Let's add these numbers. Here I get 1.354. And we want to round our answer to the least precise of our measurements. We want to look at decimal places. When you add or subtract, look at decimal places. You can see this number had 2 digits after the decimal place, and this number had 1 digit after the decimal place. You want to round it so that it has the same as the least number of decimal places. So I want to round that answer so that it's only got 1 digit after the decimal. So 13.54, I will round to 13.5. If you answer 13.54, you're not right. I know that's what these numbers add up to, but these aren't just pure numbers like you see in math. These are measurements, and we have to keep track of the precision. We can't say that this digit is 4 because we don't know what that digit is in this number. Maybe this was 1.23, and then that would be a 7 or something, right? We don't know. So the best we can do is round it off to the least number of decimal places. So when you add or subtract, round it to the smallest number of decimal places. Okay, what about when we multiply or divide? Let's take a look at this one. We got 15.3 times 4.2. Okay, if I take my calculator and I punch that into my calculator, I get 64. Let me write it down. 64.2. That's not 2.26. Okay, now this is more precise than either one of my measurements was. You can see this is a 10th place, this is a 100th place, right? It's more precise than either of my measurements was. What I need to do is I need to round my answer. When you multiply or divide, we're going to round the answer to have the same number of significant digits as the least precise measurement. Okay, so what I'm going to do is I'm going to look at the 2 numbers that I started with, and I'm going to ask how many significant digits are in each of those numbers. Let's look at 15.3. How many significant digits are in that number? The 1, the 5, the 3. They're all significant. That's 3 significant digits. I'm going to put a little 3 up here. Okay. What about in the other measurement we started with, 4.2? How many significant digits are in that number? Well, 4 and 2, those are both significant. So there's 2 significant digits there. And now I'm going to ask myself, which one had fewer significant digits? and it's the 2. The 2 significant digits is less, right? So I want to round my answer so it has that same number of significant digits. I want to round this so that it only has 2 significant digits. So I'm going to look at my number, and I'm going to say, where's the first significant digit? It's the first number in the number, right? So that 6 is the first significant digit. Where's the second significant digit? Well, it's the next digit, right? So if I want there to be 2 significant digits, I need to round my answer right there at the second significant digit. So I'm going to look at my 4, and I'm going to say, is it going to go up to 5, or is it going to stay at 4? Well, the next digit there is a 2, so it's going to stay at 4, right, because it's not 5 or over. So my 64.26 is going to round off to 64. 64 has 2 significant digits, which is the same as the least precise measurement. Alright, so from this point on, in our physics class, from here until the end of the class, every single calculation you do, every time you add or subtract or multiply or divide some things, you need to round to the correct number of digits or places, okay? Every single one, every single time. If you don't, you're wrong, okay? If the answer was 15.1 and you wrote 15.11, you're wrong. You got the wrong number of significant digits. Now I'll tell you what, on the assessment, I'll give you some points for getting the right answer, and I'll give you some points for getting the right significant digits, right? So if you don't have the right significant digits, you still get the points for having the right answer, but you won't get the points for having the right number of significant digits. And you're probably not going to get an A on the assessment without having your significant digits right. So make sure we can do this. We're going to practice this a little bit before we move on. But before we move on, make sure you could round correctly. Alright there, so we've talked about precision and measurement, we've talked about significant digits, we've talked about how to round correctly after adding and subtracting, and how to round correctly after multiplying and dividing. So hopefully that helps us to be able to attend to precision in measurements. Until next time, take it easy.